Hi, I'm Dipesh, a final year mechanical engineering student from Nepal. I've been learning machine learning on my own for a while, and honestly, I love it. But I know there's so much more to learn, especially when it comes to the real world applications. That's why I'm really drawn into this fellowship. The chance to work with the experienced mentors who can guide me through. I think that's exactly what I need right now. I want to see how the concept that I've learned get used in practice, and I'm also eager to dive deeper into the more advanced topics like NLP and generative AI. Look, I'm not here just to add another line on my resume. I genuinely want to grow my skills. I've got the basics down, but there's so much more to learn. Plus, the idea to work with the fellows who are as passionate about AI as I am, that sounds amazing. So I'm going to learn, I'm going to work hard and make the most out of this opportunity. Thank you for considering my application. Let's start our code explanation. At first, we will load the dataset and the dataset metadata. The dataset is inside the data folder. Inside the images folder, there is the images dataset, and the label indices is inside the image labels.mat file, and the speed indices is inside the set id.mat. At first, we will define the data paths, and then we will load the dataset metadata within the scipy.io.loadmat function. And next, we will extract the label and speed indices, and then we will map the indices to image path. At first, we will load and sort all the image files, and then we will create a list of image paths and corresponding labels for the training set. And then we will define the transformation. Here we will use the standard preprocessing transformation for ResNet50. We will load the pretrained weights for ResNet50 and then define the common transforms for the input data. And then we will define the train and test transformation. Next, we will create the custom dataset class. After creating the custom dataset class, we will visualize the data. We will use the plot transform images function from the utis.py file to visualize the data. Here we can see the original image file and the transform image file side by side. And then we will create the data loaders. We will create the train loader, validation loader, and test loader with the batch size of 32. At first, we will define the mini batch size of 32, and then we will create the data loader for the training and validation and testing dataset. And then we will load the pretrained model. We will load the pretrained model with the pretrained weights and refresh the final fully connected layer to the output 102 classes. And at last, we will freeze the pretrained layers except the final one. This is all for the loading pretrained model step. And in the next step, we will move the model to the device. At first, we will check if there is CUDA device available or not. If it is available, then we will move the model to the CUDA device. If not, then it's going to move to the CPU. And then we will define the loss and optimizer. We will use the cross entropy loss and add-on optimizer. Next step is the training loop. Here we are using 10 epochs, and to train the data, we will use the train model function from the train.py. We are also validating the model along with the training. So we are using the val model function from the train.py file. After running the 10 epochs, we will print out the training loss, training accuracy, and validation loss and validation accuracy. Here we can see that we have achieved 100% training accuracy and 85.74% is validation accuracy. And the next step, we'll save the model and then load the model. At first, we'll create the models directory. And after creating the models directory, we'll save the model inside the model folder. Here we can see 102 flowers ResNet50.pts inside the models folder. After our model is saved, we're going to load the state dict of the state model and use it on the loaded and use it on the instance of the model that we have just created here. And this is how we load the model. And at last, we are going to test on the loaded model. And we can see we have achieved the 84% accuracy on the loaded model.